In our last lesson, we solved quadratic systems with the graphing calculator. Today, we're going to do them by hand. Let's go over each of the methods for solving quadratics again. You want to use the square root property when you have a squared term and a constant. You'll use factoring if A is 1 and you have a product sum relationship, or if A is not 1 and you still have that product sum relationship. So I probably just scratch that part out. If you have a product sum relationship, I'd pick factoring. For complete the square, I would choose this method if A is 1 and your B value is even, so your linear term is even. Quadratic formula, I'd use as the last resort when the other methods don't work. So you could have A as 1 still, but none of these other methods are good choices. So this is not necessarily true. I would just pick when you can't do the other methods, this is the way to go. So we're going to choose the best method and solve. For the first one, I have a squared term and a constant, but I also have another variable term. So since I have that middle term, you have a B term here, you don't want to use the square root property on this one. So let's try factoring. Does it have a product sum relationship? Is there anything that multiplies to 10 and adds to negative 11? And there is. Negative 10 and negative 1. So this factors into x minus 10, x minus 1. So x is 10 and 1 are my solutions. For my next example, I have a squared term. Neither the 8 or 4 have an x on it. So I can move that 8 to the other side. And when you do that, you'll notice you have a squared term and a constant. So the square root property is a perfect choice for this. To undo the square, you just take the square root. And then move the 2 to the other side. So I'm going to add 2 to both sides. And the square root of the negative will give you an I. Square root of 4 is 2. So this is 2I. Our third example, I have x squared, but I have a 4x. So square root property is out. Whenever you have that linear term, you're not going to use the square root property. The A is 1 here, but it doesn't have a product sum relationship. There's nothing that multiplies to 7 that adds to 4. So factoring will not work on this one. Complete the square. My A value is 1 and my linear term is even. So complete the square is a good choice for this. Move the 7 to the other side. And then I want to take half of my middle term and square it. Half of 4 is 2 and 2 squared is 4. The left side is now a perfect square trinomial. So x plus 2 squared equals negative 3. Take the square root of both sides. Make sure you put plus or minus there. Square root of negative 3. Move the plus 2 to the other side, so I'm going to subtract 2 from both sides. There is not a perfect square that goes into 3. However, the negative I can pull out from underneath the square root, and that's going to be I square root of 3. On our last one, I need to move the 4x to the other side. So I'm going to subtract 4x. So in this case, I have a middle term, so square property is out. Factoring, there's nothing that multiplies to 2 that adds to negative 4. A is not 1, So quadratic formula is my only option. A is 2, B is -4, C is 1. Our discriminant is b squared minus 4ac. B squared will give you 16 minus 4 times 2 times 1. And that gives you 8. Since 8 is positive, there's going to be 2 solutions. So the opposite of b plus or minus the square root of b squared minus 4ac, which we already found is 8. And that is all over 2 times a, which is 2. Perfect square that goes into 8 is 4. So I'm going to write that as 4 times 2. That was over 4. And now this will be 4 plus or minus square root of 4 is 2. The radical 2 is left inside, and that's all over 4. And those are all divisible by 2. So if I divide that by 2, I get 2. Divide this term by 2, I'll just have the square root left of 2. And divide that by 2, and I'll have 2. That is going to be helpful as we start solving some of these below. Back from Algebra 1, you covered substitution. And the method, how you substitute in, is you solve for one of the variables in one of the equations, and then substitute in the other equation. For linear combination, you'll make one of the variables opposite in each equation. And then add the equations. So if I look below here, we're going to choose the best out of these two methods to solve this. So this first one, I have 2 lines. I don't have an x or a y by itself with a coefficient of 1 here. So substitution's not going to be real pretty on this one. I think I'll do linear combination. And you can either get rid of the x's or the y's. If I choose to get rid of the x's, 4 and 6 both go into 12. So I'll make one of the equations 12 and the other one -12. If I wanted to get rid of the y's, 5 and 2 go into 10. So I want to make one of them 10y and the other one -10y. It doesn't matter if you pick x or y's to make opposites. I think I'm going to just go ahead and do the x's. So I'll multiply the top one by a 3 and the bottom one by a -2. I could have also done -3 on the top and +2 and had the top -12 and the bottom +12. It's up to you which one you want to make positive and which one you want to make negative. Going ahead and multiplying this, my top equation will become 12x minus 15y equals 39. My bottom equation is going to be -12x minus 4y equals -96. And now I have opposites for my x's. I'm going to add them. Those will cancel. And I we'll add those and I'll get negative 19y is equal to negative 57. Divide both sides by negative 19, and y is equal to 3. They intersect at a point, and I only have my y coordinate for the point, so I need to find my x coordinate, and I'm going to plug in y is 3, and you can either use the top equation or the bottom. It doesn't matter. The top equation has smaller numbers. I'm lazy. I'm going to pick the top equation. So I'm plugging in 3 for my y. This is 4x minus 15 equals 13. Add 15 to both sides, so 4x equals 28, and x equals 7. The next example, I'll go ahead and write this as a point. So it's 7, 3. And you could plug it in and check it. My next one, notice I have my x already by itself. So there's my substitution. And I'm going to plug 1 minus 4y in for x in my other equation because x is equal to this. So instead of using x, I can use 1 minus 4y. And when I plug that in for x in my other equation, I will end up with one variable in my equation, so I'll be able to solve for that variable. So this is 3, and instead of x, I used 1 minus 4y plus 2y, and that's equal to negative 12. So this becomes 3 minus 12y plus 2y equals negative 12. I distributed my 3. Now I'm going to collect my like terms. So 3 minus 10y equals negative 12. Go ahead and subtract 3 from both sides. So negative 10y equals negative 15. And divide by negative 10, and y is equal to 1.5. I still need to find my x value. So you can either pick the top equation or bottom equation. Top one's way easier in this case. X is already by itself. You just have to plug in for y. So this is 1 minus 4, and y was 1.5. You could plug it in the other one. It's just going to be more work. And so when I simplify this, I get x equals negative 5. And so my solution for this is going to be negative 5, 1.5. Okay, next page. On this first example, I need to get y by itself. So I'm going to solve for y. So y is equal to 2x plus 5. And that lends itself nicely to our substitution. I'm going to substitute that in for y up in my top equation. So I'll have y, which is 2x plus 5, equals x squared minus 6x plus 5. This is a quadratic. I'd like to see if I can factor it, so I'm going to move these to the other side. So I'm going to subtract 2x and subtract 5. This becomes 0. And this is x squared minus 8x. And the 5's cancel out. Oh, how nice for us. This has a greatest common factor of x. So divide each of those by x when you pull that out. And so I have x equals 0 and x equals 8. But these are going to intersect at points. And so I need to plug in 0 into one of the equations. It doesn't matter which one. If I plug in 0 in the top, 0 squared is 0, minus 6 times 0 is 0, plus 5 gives you 5. And if I were to plug in 0 in this one, 2 times 0 is 0, plus 5 is still 5. So one of my solutions is 0, 5. My second one, I would plug in 8. And you can plug it in the top equation or the bottom equation. When you plug in 8, 2 times 8 is 16, plus 5 is 21. Remember, once you find your x values, to find your y values. And you could plug in both points into both equations and make sure that they work. For our second example for the linear quadratics, I have a quadratic here and then a line. Notice they're already solved for y, so I can just plug in x plus 1 in for y in the top equation. And I'm going to move everything to one side and set it equal to 0. So I have 0 equals 3x squared minus x minus 2. Square root property is out solving this. I have that linear term here. I'm going to see if it factors. Can I think of anything that multiplies to negative 6 that adds to negative 1? I can. So I'm going to split the middle on this one. So multiplies to negative 6, adds to negative 1, and those numbers are negative 3 and 2. So I'll still have my 3x squared and my minus 2, but instead of having negative 1x, I'm going to write negative 3x and 2x. That still would give me that negative 1x. Group, group. My first group has a 3x in common. I'm left with x minus 1. My second group has a 2 in common, and I'm left with x minus 1. They each have an x minus 1, and when I take out the x minus 1s, I'm left with 3x plus 2. And so my solutions for x are 1, and then I can take the opposite of that and divide it by my coefficient. So that's going to be negative 2/3. I still need to find my y values. So plugging this in, and you can plug it in the top equation or bottom equation, but look how easy the bottom equation is. So plug in 1, 1 plus 1 is 2. Plugging in negative 2/3, negative 2/3 plus 1 is 1/3. Frequently, people find x but forget to find the y's. And you should double check your answers and make sure that they work. For the next two examples, we're going to be solving quadratic quadratics. And notice I have y equals, so I have my substitution for y. So 2x squared minus 2x plus 3 is equal to x squared plus 5x minus 7. Let's move everything to one side. I like my x squared positive, so I'm going to move the x squared here and not the 2x squared. So subtract x squared, subtract 5x, and add 7 to both sides. And you'll get x squared minus 7x plus 10 equals 0. I can't use square root property because I've got that middle term. I need just a squared term and a constant to use the square root property. Let's see if it factors. Can you think of anything that multiplies to 10 that adds to negative 7? You can. And so that's going to be negative 2 and negative 5. So it factors into x minus 2, x minus 5. And so my x values are 2 and 5. Plugging in 2 squared is 4, plus 5 times 2 is 10. So that's going to be 14 minus 7 will give me 7. You could have used the bottom equation too, but that looks, you have to take it squared and then multiply by 2. I didn't want to do that much work. On the top, again, plugging in 5, you get 5 squared, so 25, plus 5 times 5, that's 25. 25 plus 25 is 50, minus 7 gives you 43. And you could use your calculator. I'm just doing that in my head. Last example. I have y by itself here. So I'm going to substitute that in for this y here. So I have 2, and this is x minus 1 squared plus 4, and that's equal to x plus 2 squared. This one's kind of ugly. This is a perfect square trinomial, so I'm going to do square, double square. You could FOIL it out if you want to. So square the first term, multiply those together and double it, so that'll be minus 2x. Square the last term, that gives you plus 1. And I still have that plus 4 on the outside. So this is multiplied by 2. That 4 was not multiplied by the 2. On the other side, I'm going to use square, double square as well. So x squared, multiply the first and last together and double it. So that's 2x times 2. That gives me 4x. And then square the last term, so I get plus 4. Distribute the 2. So this is 2x squared minus 4x plus 2 plus 4. And that's equal to x squared plus 4x plus 4. There's quite a bit of algebra in this one. Let's combine our like terms. So 2x squared minus 4x plus 6 is equal to x squared plus 4x plus 4. I want to set this equal to 0. This squared term is larger than this one, so I'm going to move this one to the other side. So let's subtract x squared, subtract 4x, and subtract 4 from both sides. And so I end up with x squared minus 8x plus 2 equals 0. I cannot use the square root property since I have my linear term here. Factoring, is there anything that multiplies to 2 that adds to negative 8? I am out of luck. However, this does have a leading coefficient of 1 and a term that is even. So complete the square I can do. I don't have to do the quadratic formula on this. So skip a little bit of space, put the 2 on the other side, and then you're going to take half of your middle term, your linear term, which is negative 4, and square it. So I'm going to add 16 to both sides. This is now a perfect square. So x minus 4 squared is equal to 14. Then I'm going to take the square root of both sides. And then I'm going to go ahead and add 4. This is the exact answer. Or if you want a rounded answer, which we're going to probably need to use, let's go ahead and do 4 plus the square root of 14. And so that is about 7.74 for that one. And then 4 minus the square root of 14 is 0.26. I just have my x values. I still have to find my y values. So the exact answer wasn't too helpful finding your y values. So plugging in 7.74, if you wanted to use the exact answer, you could. I'm going to do x, or 2, and then parenthesis, x, which is 7.74, minus 1, and I'm going to square it. And that gives me 90.86. And when I plug in the other one, 2 parenthesis x, which is 0.26 minus 1 squared, I'm plugging it into the top for both of them. That gives me 1.095, so that would round to 1.10 if I'm going to the nearest hundredth. And that completes our long set of notes today. Sorry, guys.